from benzene, and obviously the preparation of benzene as well from acetylene. And then after the formation of benzene diazonium chloride, we will discuss about the reactions of benzene diazonium chloride. It is one of the most important topics in organic chemistry as far as NEET, JEE or boards is concerned. In case of boards, you will get the sequence questions, and in case of NEET and JEE, you will get the fill in the blanks questions, and obviously the questions where consecutive reactions are given and you have to guess the product. So starting benzene diazonium chloride, we will first require to know about how benzene is formed. Basically, we have learned about how acetylene is formed, or acetylene actually in the presence of red hot tube transforms into benzene. So we will first show that. So today's topic is benzene diazonium chloride. Let's change the color first. Let's zoom it more. Benzene diazonium chloride. Okay, so our topic is benzene diazonium chloride. I will send you the notes on Telegram, and I will discuss about the Telegram channel and group at the last of the video. So benzene diazonium chloride is today's topic. We will change the color of the pen. First, we will take acetylene. This is acetylene. Now you may ask why this compound is actually ethyne or eth1-ine. Then why it is called acetylene for common name? That's because acid word is used for two carbon structure is called acid. This is basics of IUPAC nomenclature. I will show you IUPAC nomenclature later on in a YouTube video, but this is my first lecture here on YouTube as far as chemistry is concerned. So this is acetylene. From acetylene we will use red hot tube to transform it into benzene. So we will use red hot tube. This reaction is a part of the chapter hydrocarbons. So we will use red hot tube, and 3 moles of acetylene will transform into something like this: CH, triple bond CH, CH, triple bond CH, and CH, triple bond CH. So obviously plus minus will be there here. And we know that the electron shifting occurs from the electron shifting order is from nucleophile to electrophile. Like this. So in this case, both are carbon. We can choose any one as nucleophile, any one as electrophile. So from plus to minus, obviously it is giving away the electron. That means positive charge will be left behind. And in this case also like this. And they all join together here. Yes, they all join together. To form a structure like this. This is benzene. So this was a basic preparation of benzene from acetylene, and this is one of the first reactions where we will see the formation of benzene directly in organic chemistry. So we have learned 3 things here. First is that how the reaction takes place. second, the condition for the reaction, and the third, that is the electron shifting order. Now you may think that okay, benzene is formed already. What is the formula of benzene? The formula of benzene is C6H6. The formula of benzene is C6H6. So obviously, if it is C6H6, we will understand that from benzene we will get so many common names of different compounds that I think most of them are very important. So we will first use benzene to form certain products. I will not show the reactions here, but from benzene I will show different common names of compounds, so that you can use them later on when we progress to the next part of different chapters. So something like this, where benzene, at the top of benzene you have CH3, which is methyl benzene, is called as toluene. Next, if it is OCH3, which is methoxybenzene, then it is called as anisole. If it is OH here directly, then it is phenol. If it is COOH directly, then it is benzoic acid. And so on. So first I will show you how the different compounds of benzene are named according to IPAC. So basically this is benzene. There are three rules actually, that if benzene, from benzene we have CH2 and one bond left, then this is called benzyl. Next, if one hydrogen is left, CH, and two bonds are open, then it is then it is benzyl. And obviously it is, if it is like this, three are open, then it is benzo. I will show you examples as well. Of this thing. Okay, just the handwriting is a bit messed up here. I will send you the notes on Telegram, so no need to worry. So I will show you examples of benzene structures, of formulas derived from, of compounds derived from benzene. If it is something like this, it will be called as benzyl chloride. If it is something like this, this will be called as benzaldehyde. And if it is something like this, no hydrogen involved with carbon, only three bonds, two with oxygen, one with OH, then benzoic acid. So all of them, you can see, they correspond to what I have written here. You can see here, this part and this part. We have learnt about benzyl and benzo, and in this part you will understand that benzyl chloride has CH2Cl, so two hydrogens, and one hydrogen here, benzal, two hydrogen, benzyl, and no hydrogen, and three bonds with carbon is benzo. So definitely it corresponds to what I have written previously. So just revise this one. I've shown you some basics about benzene as well. Now we will go into benzene diazonium chloride. You can note it down if you want. Pause the video and note it down, or you can actually go with me. I hope it is done. So we will go to formation of benzene diazonium chloride. So formation, as far as formation of benzene diazonium chloride is concerned, we cannot directly form benzene diazonium chloride from benzene. So we will need intermediates here. What will be the intermediates? First of all, the next topic is formation of BDC. No need to worry, BDC is nothing complex. Formation of benzene diazonium chloride. Formation of benzene diazonium chloride requires some steps. So first we will learn about, so from benzene we will transform it into aniline. How to transform it into aniline? This is benzene, this is benzene, this is benzene, and from benzene, okay, so formation of benzene diazonium chloride. Okay, so okay, there was a distraction actually. Formation of benzene diazonium chloride. From benzene we will transform it into nitrobenzene. How to transform it into nitrobenzene? We will use the reagent concentrated nitric acid, and concentrated sulfuric acid, concentrated nitric acid and concentrated sulfuric acid. As a result NO2 plus NO2 plus NO2 plus electrophile is generated. NO2 plus electrophile is generated, and it adds on to benzene like this. Adds on to benzene like this. There's a mechanism as well, but in this case I am showing you about benzene diazonium chloride, so we won't need this here. From NO2 you will use reducing agent like tin, HCl. We will use tin and HCl and Fe and HCl. Anyone you can use. So this transforms it into aniline. Aniline is nothing but a primary aromatic amine. It is a characteristic smell as well. So aniline is a 1-degree aromatic amine. From aniline we will use different reaction steps to form benzene diazonium chloride. Now we will go to the next part of how this is the basic reaction here. Aniline, if we add to it NaNO2, that is sodium nitrite, plus hydrochloric acid at 0 degree to 5 degrees Celsius, we get benzene diazonium chloride. How does it look like? It looks like this. This is BDC. Now why is 0 to 5 degrees Celsius chosen? Why is a cold temperature chosen? Because nitrogen is a good leaving group. And if high temperature is given, it will escape out. Nitrogen is a good leaving group, and if high temperature is given, it will escape out. That's because nitrogen with 3 bonds here. Nitrogen has 3 bonds here, you can see. So it is very stable, because in case of N2 as well, we get 3 bonds here. So it will just escape out. So we need a very low temperature for the reaction to take place successfully. Now we will go into the mechanism, which is the main part here. I just zoom it. So in case of mechanism, first we will see how this takes place. NaNO2 plus HCl, which is the reagent. From NaNO2 plus HCl we get HNO2 nitrous acid plus NaCl plus NaCl. So HNO2 we can write it as HONO, HONO. It's the same actually. HONO in the presence of acid, that is H plus, we have lone pair of oxygen. It will give it to H plus, thereby forming, it will be protonated actually like this, NO, just protonation. And obviously oxygen cannot have plus charge, so it will just escape out. It will just escape out and leave behind. It will take nitrogen's electrons because of its high electronegativity and just leave behind NO plus electrophile. This is an electrophile obviously because it has positive charge. It needs electrons, so it loves electrons. That's why it's electrophile. Electrophile, that means electrophile means electron loving. So now we will take aniline once again. This is aniline. N, H and H, and nitrogen has lone pair, NO plus. Nitrogen lone pair, they will be given to plus N and form N, H, and obviously after giving the electrons it will be having plus charge, N double bond O. Now what happens is that one hydrogen will be given out, that is H plus will be given out, and it will form N double bond O and H. Now tautomerization will take place here. How will tautomerization take place? Hydrogen, this is first position, this is second, this is third. So hydrogen will be given to, from third, hydrogen will be given to 1. And this double bond will be given to here. So tautomerization will take place. To form pH N double bond N OH. OH has lone pair here. Now the H plus that was given away earlier, it will give its lone pair to H plus and thereby form pH N double bond N OH2. That is, another protonation will take place and H2O will go away. Now this forms pH N double bond N plus, and here we have the lone pair. It will give to the plus part and thereby a triple bond will form here, where pH N, positive charge on the nitrogen, a triple bond, and N. So it looks like this here. N, triple bond, N, and we have plus. Now if Cl minus is given, here we have the lone pair, Cl minus is given, it transforms into something like this. Which is called benzene diazonium chloride. Benzene diazonium. Diazonium. Benzene diazonium chloride. Chloride. So we have got our benzene diazonium chloride from aniline, and I've explained to you about benzene, the formation of benzene using red hot tube, and obviously the formation of benzene diazonium chloride. Now this was the formation of benzene diazonium chloride, and I'll make another video. I'll explain the reactions of benzene diazonium chloride. So most of the chapter amines will be covered, because generally benzene diazonium salts are covered alongside amines, and later on I will start the lectures of IPAC, isomerism, general organic chemistry, then hydrocarbons, haloalkanes, haloarenes, and aldehyde ketone carboxylic acids, alcohol, phenol, ether, etc., and all the chapters of chemistry and physics. So I'll just sharing you the link of the Telegram channel. The channel name is NEET 650 plus, NEET 2025 650 plus. We have a group linked with it as well, so you will be able to discuss. So the joining link is, I'm just writing it here. The joining link is https t.me slash NEET 2k 251. This is our Telegram channel link, and you have a group attached with it as well, our TG channel link. It is a new channel, so obviously there are 1 to 2 people currently. We will post regular updates about NEET, and obviously regular notes, quiz sessions, and everything, doubt solving, etc. will be held. We will have a competitive ambience here in the group and the channel, and I'm obviously new here, so a few days may be required to bring everything on track, but I promise that the syllabus will be completed on time by March itself, and regular quiz sessions will be held, question practice sessions will be held live on Telegram and YouTube as applicable. So this was it. Thank you. This was our first video, so I didn't take more than 20 or 25 minutes. I showed to you the entire formation of benzene diazonium chloride with its mechanism. So in the next video I will ensure that this part is revised carefully, and then I'll move on to the reactions of benzene diazonium chloride and complete it, and then start the IPAC part. I'll complete IPAC in one shot, so it will be a longer video. I'll break it into parts so that it's easier for you to grasp concepts. Okay then, thank you and goodbye. The notes will be uploaded on the Telegram channel.